All right, part 2, graphing trig functions. We're going to talk about period and amplitude change. So right now you should graph the parent sine and cosine curve and then come back to see if you've done it right. So you should hit pause here and graph the parent sine cosine. Okay, this is in radians. Can you do it in degrees? Yes, but you really should start getting used to radians. Starts at the origin. The high point is 1. The low point is -1. And this is one cycle. They call it the period. And here is the cosine curve. So we're going to actually put some letters on here. A sine B theta. This is the equation for a generic sine and cosine curve. In these parents, A is the amplitude, and in the parent, that is 1. And the same is true for cosine. A is the amplitude, and in the parent, it is 1. B is super important. B determines the period. B determines the period. And remember, the period is the length of the wave, the length of a cycle. So in the parent, that period is 2 pi. But you know what? I might be able to fit more than one wave from 0 to 2 pi. Maybe I can fit 2 waves in. Maybe I can fit a wave and a half to figure out the period. 2 pi over B. Okay, you should draw. I'm going to do 6 examples. So draw 6 grids for yourself, push pause, and then come back when you're ready. Okay, so I'm going to draw y equals 3 times the sine of theta. Okay, well, here A is 3. So that means my amplitude is going to be 3. B is 1. B is the coefficient on theta. So this is really, honest to goodness, pretty basic to do. Normally the amplitude is 1. So I don't know, let's put 1 here. But now the amplitude is 3. 3. But I haven't changed the period. So I'm just going to label pi over 2, pi, 3 pi over 2, 2 pi. And then I'm going to graph a sine curve starting at the origin. And instead of going to 1, I'm going to go up to 3 and back down to 0 at pi. And then at 3 pi over 2, instead of going to -1, I'm going to go to -3. And then back up to 2 pi. And then I'm going to connect the dots. And that's it. That is how you graph a sine curve with an amplitude of 3. How about something like -2 cosine theta? So the period has not changed because B is 1. So therefore the period is 2 pi. But the -2, so I'm going to reflect it. The amplitude is still 2. This is super important. The amplitude is 2. The negative tells you that it is reflected. No such thing as negative height. And remember, amplitude is the height. So I'm going to write off to the side here. The amplitude is 2, and then this is a reflection. Don't tell me the amplitude is -2. That's not possible. You can't have negative height. Okay, so it doesn't matter your increments as long. What I'm looking for is that you have the -2 and the 2. And the period is 2 pi. So You might be thinking, oh, you went 3 spaces in this particular problem and 2 spaces in the previous problem. Who cares? 1, 2, 3. 1, 2, 3. Okay, so cosine normally starts at the high point, and then 0, and then the low point, and then 0, and then the high point, which is right here. Oh, no, 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 no. I messed it up. It's supposed to be a reflection. So instead of starting at the high point, good thing I'm using an erasable pen, huh? Instead of starting at the high point, I'm going to start at the low point. Instead of starting at the high point, I'm going to start at the low point. Pretty good. Not too bad. That's a little messed up. Okay, so what happens when you have a change in the period? Let's say you have a change in the period. And so if you watched the last video, I talked about high notes and low notes. That's what happens when you change the period and amplitude. We're going to do period first. Okay. Sine of 2 theta. The amplitude is 1. A is 1. Okay, B is now 2. So if you remember, I said B determines the period. So this particular graph doesn't have a period of 2 pi. It has a period of 2 pi over B. The period is pi. Okay, so if the period is pi, normally, I'm just going to kind of graph this out here. Pi over 2, pi, 3 pi over 2, 2 pi. Okay, so normally the function would look like such. Okay, that would be what the graph normally looks like. But this is a period of 2 pi. Now I need a period of 1 pi. So that means I have to squeeze in 2 waves. Well, if I take 2 pi and I split it up into 2, that means that each wave is now 1 pi. Okay, this is the part that some of you are going to be like, oh my God. There are 4 quadrants in the unit circle. This period is pi. Pi over 4 is each interval. Watch how this works. Normally it's pi over 2. Now it's going to be pi over 4 for each interval. 3 pi over 4. 5 pi over 4. You may have to zoom in. 7 pi over 4. All right, so now I'm going to graph this. It's going to start at the origin, and instead of reaching its high point at pi over 2, it's going to reach its high point at pi over 4. Then it's going to hit the x-axis. And instead of reaching its low point at 5 pi over 4, it's going to reach its low point at 3 pi over 4. Here is my first wave. Keep going. 5 pi over 4, 3 pi over 2. I messed it up here a little bit. And there is how you graph the sine of 2 theta. Each interval was pi over 4. Okay, so how about something like that doesn't divide so nicely? So how about I ask you to do y equals the cosine of 3 theta. Okay, that means that there has to be 3 waves between 0 and 2 pi. Okay, so you have a pi. whatever, you got a pizza, and you're splitting it among 3 people. Boom, boom, boom. Looks like a peace sign, huh? So I'm splitting up this pizza among 3 of my friends. We are each going to get 2 pi over 3 slices, or 2 pi over 3, I don't know what you want to call it, like area of the circle. So 2 pi over 3 is the period. Okay. I'm randomly putting 3. 1, 2, 3, 4. Okay, and it's going to start at the high point. And it's going to go down, and then it's going to reach the next point. So I think I'm going to do that first. It might be helpful for some of you. Boom, 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 boom. I'll fill in the exact increments, like what numbers are those that I'm plotting. Okay, so there's a cosine curve. Oh, Miss Babby, it looks like it's the same length as this one. Sure, but I'm going to make it look different by changing the increments. Okay, each piece from here to here, from beginning to end, needs to be 2 pi over 3. From beginning of the curve to the end of the curve is 2 pi over 3. How'd I get that? Because the period is determined by taking 2 pi, 1 rotation, and splitting it up, whatever b is, and b in this case is 3. I need to have all these increments labeled. All of your graphs have to have 4 increments per cycle. This is 1 cycle. All right, well, how many quadrants are in the unit circle? 4. So I'm going to take 2 pi over 3, and I'm going to divide it up over 4. So you always take the period over 4. You always take the period over 4 to determine the intervals. So let's see, 2 pi over 3 over 4, I believe, is pi over 6. Yeah, pi over 6. Each interval is pi over 6. So from the origin to the first interval is pi over 6. Another pi over 6 is 2 pi over 6. Pi over 3. Another pi over 6 is 3 pi over 6. Pi over 2. Another pi over 6 is 4 pi over 6, which is 2 pi over 3. All right, one more. I know I said 2, but we're going to do one more. We're going to do an amplitude and a period change. So let's say I give you y equals -4 times the sine of, how about theta over 2? Amplitude is 4. The amplitude is never negative. A is negative. The amplitude is 4, and it is a reflection. Okay? All right, and then B, be careful, B is 1/2. Therefore, the period is 2 pi over 1/2, which is 4 pi. The period is 4 pi. So this wave is stretched out. This wave, see how this one was compressed together? This one is stretched out. So your intervals, 4 pi over 4. Those are my intervals. 1 pi, 2 pi, 3 pi, 4 pi. And it's a reflected sine curve. So it starts at the origin, goes down to the minimum, back to the axis, up. And there is graphing with amplitude and period changes.